Today we're going to be solving quadratics using the quadratic formula. When a quadratic equation cannot be factored, we can use the quadratic formula to determine its solutions, whether they be real or complex. So at this point, how have we solved quadratics? We've solved quadratics by factoring, we've solved quadratics by completing the square, and today we're going to be solving quadratics using the quadratic formula. Now, you've already been introduced to imaginary numbers, complex solutions. Today's lesson will include complex solutions. The quadratic formula, I learned this handy dandy little song when I was in high school, well over 20 years ago. And we would sing it like this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that helped me remember the quadratic formula. Now, you don't necessarily have to memorize it. It's usually on every formula chart I've ever seen for any test. But that helped me memorize the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's the quadratic formula. We also have this little thing called the discriminant. And the discriminant is part of that quadratic formula. It's actually what's underneath the radical. It's this b squared minus 4ac. B squared minus 4ac. That's called the discriminant. That tells us the number and types of roots the quadratic has. So I'll tell you what that means. If that number that's underneath the radical is greater than 0, so it's positive, your quadratic will have 2 real roots. So this means your radicand, remember that vocabulary word? Your radicand is positive. If the number that's underneath that radical is negative, so it's less than 0, you'll have 2 complex roots. So, you know that you'll be taking the square root of a negative number, and you can't do that without imaginary numbers. So you'll have 2 complex roots. So that's where your radicand is negative. And then if that discriminant is equal to 0, then that means you're going to have 1 real double root, right? I like to say it's a double root because that's where your vertex of your quadratic is. That's where it changes direction, okay? And it goes from increasing to decreasing or decreasing to increasing, whichever way you are moving. But that's what your discriminant tells you. So just by finding that b squared minus 4ac, that can tell you a little bit about your quadratic. So let's move on and let's start working with some of these examples. Now you may want to refer to your formula up there, but I will be singing as I'm working through these problems. So let's go to example number 1. So we want to make sure that our equation is in standard form. We've replaced f of x or, y with 0. And we're looking for what is x when y is 0. And we want to identify the values of a, b, and c. A is 1, right? It's the coefficient of x squared. B is negative 4, and c is negative 5. So let's now plug this into our formula. And what I'm first going to do is I'm going to write out what's called the quadratic skeleton or quadratic formula skeleton. And it's x equals the opposite of, every time I say a letter, I'm going to put parentheses instead of the letter. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula skeleton. And then I'm going to put inside of those parentheses the values of a, b, or c. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And now we need to simplify this one part at a time. So x equals the opposite of b, the opposite of negative 4, that's positive 4, or negative negative, right? That together, that's a positive, plus or minus, and then we're going to simplify And we're going to find the discriminant first. -4 squared, I'm just going to condense this down using my order of operations. -4 squared is positive 16. And then I'm going to do the second part, right? -4 times a times c. So -4 times 1 is -4. -4 times -5 is positive 20. So I get plus 20 over 2 times 1 is 2. And now we're just working our way down. X equals 4 plus or minus, what is 16 plus 20? It's 36 over 2. So we're just simplifying a little bit at a time. What you want to do first, though, is simplify that discriminant. Okay, so now I can see my discriminant is positive, right? And I'm actually going to write that down. The discriminant is positive. It's greater than 0. So what does that tell me? I'm going to have, therefore, 2 real roots. Whoop, 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 whoop. Okay, so now that's actually a perfect square. 36 is, it's 6, so that's going to be really easy. X equals 4 plus or minus 6 over 2. Plus or minus, we are going to set up 2 cases. So x equals 4 plus 6 divided by 2, or x could equal 4 minus 6 divided by 2. So in this first case, x equals 4 plus 6, which is 10 divided by 2, which is 5. Or 4 minus 6, which is -2 divided by 2, which is -1. Those are my solutions. They are real. This is where this quadratic really crosses the x-axis. And in fact, this quadratic is factorable. So, but I just wanted to show you that you could factor this, and that would have been way easier. But it also works if you use the quadratic formula. It works every single time. So x equals -1 and 5. And I know when I've given like tests or quizzes in the past and I've said I don't care how you determine the solutions to the quadratic, but you have to do it without using your calculator. And if they couldn't remember how to factor, but they could do the formula every time, that's fine. Okay, let's move on to number 2. In example number 2, I'm going to identify A, which is 2, B, which is 6, and C, which is -9. And I'm going to plug it into my formula, and I'm not going to use the, or actually, in this case, you know what? I'll go ahead and use the quadratic formula skeleton again, because I definitely know that some students really appreciate it. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Bet you would never know I went to choir camp for 3 years when I was younger. Whew. Didn't do me much good. Okay, x equals the opposite of b, b goes here, plus or minus the square root of b squared minus 4 times a times c. I didn't even write c equals, whoops, c equals, all over 2a. And now let's start simplifying it. X equals the opposite of b, that's -6, plus or minus, let's simplify this discriminant. B squared, 6 squared is 36, minus 4ac time, or minus 4 times a times c, or -4 times 2, which is -8. -8 times -9 is positive 72 over 4. And I'll change colors here just because I like to. Okay, so x equals -6 plus or minus. Let's simplify this. What is 36 plus 72? It is 108. And this is, oh, let me close that right there. This is, my discriminant is greater than 0, therefore I'm going to have 2 real roots. Not that you need to point this out every single time, but that's what that tells me. Then divided by 4. So now we're going to simplify this square root right here. It's not in simplest terms, and we need to simplify it. So the square root of 108, I'm actually going to do this right up here in this little place, the square root of 108. We can simplify this. The biggest perfect square, I know 4 goes into 108, but is there a perfect square that is bigger that goes into 108? 36. 36 times what? 36 times 3. So the square root of 36 times the square root of 3, what is the square root of 36? It's 6. I can simplify this as 6 square roots of 3. So I'm going to rewrite that radical portion as x equals negative 6 plus or minus 6 square roots of 3 divided by 4. What we're going to do now is simplify this expression. So again, I've told you in previous videos to treat your radicals like they're variables. So if I had something like negative 6 plus or minus 6x, what could I factor out? I could factor out a 6 or a negative 6. So let's do that. Let's factor out a negative 6, and I'm going to be left with positive 1 plus or minus 1 square root of 3, or just square root of 3, over 4. And now I have a lot of students wanting to simplify, like this up here is an expression you cannot touch. Like you can't simplify anything individually with your denominator unless you pull something out, unless you factor something out, which is what we just did. And so now we can simplify this negative 6 and this 4. I can divide both of those numbers by 2, and I'll get 3 and 2, and that's how I would simplify this. And this would be x equals 3, negative 3 times 1 plus or minus the square root of 3 over 2. And if you had something like, if you factored out a positive 3 and wrote 3 times negative 1 plus or minus, that's fine too. Okay, that works. Okay, so let's move on. That's my answer. And I do have to say, if you needed to, like, plug this into your calculator and get the approximate decimal point of your solution, then you could do that. Just make sure that whenever you do this, that you plug in what's in your numerator in parentheses and then divide it by your denominator. So let's move on. The quadratic formula. Let's go to example number 3. In example number 3, and now I'm going to be going through these a little more quickly because I'm not going to draw that quadratic formula skeleton. I'm just going to sing the song and write it out as I'm singing it. But first, let's identify A is 1, B is 8, C is 16. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And that's how I'd plug that in. And now let's simplify a little bit at a time. The first thing I want to do is simplify the discriminant. Let's find that discriminant. So plus or minus 8 squared is what? 64. Negative 4 times 1 times 16 is negative 64 over 2. And in this case, I get x equals negative 8 plus or minus, what is 64 minus 64? It's 0. So I get the square root of 0 over 2, which tells me when I have a radicand that is 0, where the discriminant is 0, that means I have one real root. That's my double root, which means my vertex is on the x-axis. Okay, that's where it's going to change directions. So if I have negative 8 plus or minus 0 over 2, then that means x equals negative 8 over 2, which is negative 4. And that's the solution. It's going to cross that x-axis, or it's going to hit that x-axis. It's not going to cross it. It's going to hit that x-axis and bounce off at x equals negative 4. Let's move on to our fourth example. First, let's identify A, B, and C, the value, and we want to make sure it's in standard form. So if it's not, put it in standard form. You might need to move some things around. But in this case, A is negative 2, B is 4, C is 7. Let's plug it into our quadratic formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And I plug those in. And I didn't put like the parentheses around the opposite of B on the outside just because I know the opposite of 4 is negative 4. So now let's move on and let's simplify what this radicand so that we can find out our discriminant. Plus or minus 4 squared, that's 16, minus, or negative 4 times negative 2 is positive 8. 8 times 7 is positive 56. So plus 56 over 2 times negative 2, which is negative 4. And let's move on. And now we're going to add those two numbers underneath our radical to get 16 plus 56 is 72 over negative 4. And I want to simplify the square root of negative 72. I know I can simplify it, but it's not a perfect square. Yes, it's a non-perfect square root, and I know I can simplify it. So the square root is 72. What's the biggest perfect square that goes into 72? 9 does go into 72, but there's a bigger perfect square that goes into 72. Square root of 36. 36 times square root of 2. What is the square root of 36? It's 6. 6 times the square root of 2 is the square root of 72 simplified. So now I'm going to rewrite x equals negative 4 plus or minus the square root of 72 can be written as 6 square roots of 2 over 4. What do we do at this point? We're going to factor out a GCF from our numerator. What can I factor out? I can factor out, you know what, there needs to be a negative there. I can factor out a 2 or a negative 2. In this case, I'm going to factor out a negative 2. What am I left with? Positive 2 plus or minus, and it doesn't matter because I have a plus or a minus. Positive 2 plus or minus 3 square roots of 2 over negative 4. And let's see, at this point now, and again, I always have students wanting to like simplify this 4 right here and this 4 down here, negative 4, negative 4. You can't do that. Do not do that until you factor something out. So like the little trick that I'm always telling my students is unless you have a number right here, like in front of your parentheses, you can't simplify your numerator and denominator. Okay, so now I can because I do. Negative 2 and negative 4 can simplify to 1 over 2. And I can rewrite this as x equals 1 times all of that is just 2 plus or minus 3 square roots of 2 over 2. And that's my answer. In simplified square root form, again, if you needed to find your decimal, you would do open parentheses 2 plus 3 square roots of 2 close parentheses divided by 2. Or open parentheses 2 minus 3 square roots of 2 close parentheses divided by 2. Let's move on to example number 5, our last two examples. In example number 5, let's identify A, B, and C. Hopefully you're getting more comfortable with this. A equals 1, B equals 3, and C equals 4. And let's work through this. If you need to pause the video, try to do it yourself, go ahead. I'm going to sing the song. It may be annoying for you at this point, and I'm really sorry. But you will probably remember this when you're like 30 years old, and even if you've forgotten what it goes to, you will remember the formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And there we go. And now let's simplify the discriminant. So x equals negative 3, or find the discriminant if you will. The square root of 3 squared is 9. Negative 4 times 1 times 4 is negative, did I do that right? Again, that is not 2. That is not, or 1. That is 2. I didn't even identify it right. 2 2, 2. Okay, going crazy here. So A equals 2, B equals 3, C equals 4. Okay, that's what it should be. Sorry about that. So I like to make these mistakes on purpose, just to make sure, you're on your toes. So negative 4 times 2 is negative 8. Negative 8 times 4 is negative 32 over 4. X equals, what do we do now? We get negative 3 plus or minus, and then let's simplify our radicand. 9 minus 32, negative 23 over 4. So this is our first example where we have a discriminant that is negative. When our discriminant is less than 0, what does that mean? That means we'll have two complex roots. That means that if you graphed this quadratic on a coordinate plane, it would not really cross your x-axis, which means you don't have any real solutions. You have two complex solutions or complex roots. When you have a negative underneath your radical, you're going to pull the I out. You're going to have an I somewhere in your answer. Because, remember, I is the square root of negative 1. So if I have the square root of negative 23, which I cannot simplify the square root of 23, I'm going to rewrite it just like this. Negative 3 plus or minus I times the square root of 23 over 4. And that's my answer. So you're not going to leave your answer with a negative underneath your radical. You're going to pull an I out. Anytime there's a negative underneath your radical, you're going to have an I in your answer. And in this case, we can't simplify the square root of 23. It is a non-perfect square, but we can't simplify it any more than it already is. So we're going to leave it just like that. And that's our answer. On number 6, moving on. It's in standard form. I can't zoom in this much. It's going to start causing problems. Oh my gosh. Okay, I'm going to identify A, B, and C. A is negative 1, B is 4, and C is negative 7. And now we're going to plug these values into our quadratic formula. So X equals the opposite of B plus or minus the square root of B squared minus 4AC. Oh gosh, it's giving me problems. All over 2A. And 2 times negative 1. I gotta zoom out a little bit. It seems like my screen does this whenever I zoom in a little bit. Okay, so let's change colors here. And let's simplify what's underneath our radical. That's our discriminant. So X equals negative 4 plus or minus 4 squared, which is 16. 16, I don't know why I put that in parentheses, but there you go, it's fine. And then negative 4 times negative 1 is positive 4. Positive 4 times negative 7 is negative 28. So minus 28 over negative 2. Okay, and then maybe I'll just write a little slower on here. And now let's simplify it even further. So X equals negative 4 plus or minus the square root of negative 12 over negative 2. And now we need to simplify the square root of negative 12. And I'm going to do that off to the side over here. I know since there's a negative underneath my radical, I know I'm going to pull an I out, right? So I know I'm at least going to have an I in my answer somewhere. So 12 can be simplified. The biggest perfect square that goes into 12 is 4. 4 times what is 12? 4 times 3. So I can rewrite this as a square root of 4 times the square root of 3 times the square root of negative 1. What is the square root of 4? It's 2 times square root of 3 times I. And I would write it as 2I times the square root of 3. So when I rewrite this, I get X equals negative 4 plus or minus 2I times the square root of 3 over negative 2. I'm not done in this case. I can actually factor something out of my numerator. Remember, you can't just go on and simplify negative 4, negative 2. I have a lot of students that want to do that. I have to factor something out first. If you treat that I root 3 like it's a variable, what could you factor out? I could factor out a 2. In this case, I'm going to factor out a negative 2. So I'm left with positive 2 plus or minus. And you always want to like switch that sign if you're factoring out a negative, but it doesn't matter in this case because I've got two cases here. One's positive and one's negative, or one's plus, one's minus. 2 plus or minus I times the square root of 3 over negative 2. And now I can simplify crossing out my negative 2. Now I can do that, right? So your kind of like trick that you're looking for is there's a number in front of those parentheses, okay? Not just like you need to have something in front, like out in front. So you're just left with x equals 2 plus or minus I times the square root of 3, and you don't need to write that over 1 because it's assumed to be over 1, right, if you don't have anything in a denominator. So there's your answer. And that concludes your notes over solving quadratics using the quadratic formula, including complex solutions. I hope it was helpful.